Here I am in Siemens LMS Testlab Desktop Advanced. Today we're going to be looking at offline RPM extraction. The first thing I'm going to do is go to Tools, Add-ins, and turn on the Offline RPM Extraction add-in. What this tool will allow you to do is extract an RPM trace from a time-based color map calculated with the vibration or acoustic throughput data you collected. So when I turn that add-in on, you'll see that the RPM extraction workbook shows up below. So the first step is to go in and grab your throughput data and replace that in your input basket. Then go to Time Data Selection, make sure the source is selected on Input Basket and click Replace, which will load your time traces. Then go to RPM Extraction and click Make Trace List. This is going to pull the data out of that time data selection and import it into the RPM extraction workbook. The first step in this workbook is to calculate that time-based color map. So select one of your traces by clicking on this Select column here, and whichever trace this blue box is selected on is the trace that will be used for your color map. Then you hit Calculate Spectral Map, which will load the map here. What we want to see in our spectral map is a well-defined order line like we see here. For RPM extraction to work, you need to know which order is this well-defined order line. So in this case, I know that this is my second order. So what I'm going to do is take this cross-haired cursor, drop it on the order, and click Accept Point. And when I take this cursor away, you can see that this point that I dropped remains there. Now I'll come down to Order and make sure that the order number here matches whichever order that my point was dropped onto. Then I'll hit Predict Curve, which will predict this order line. And then finally, I'll hit Calculate RPM, which will update the RPM trace down here. To save this out as a new run, type in the run name that you want to use and hit Save. Now when we go back into the navigator, you'll see that a new run name was created, and it'll contain all the throughput data that you had imported into RPM extraction, along with a new channel which is named 5555:RPM extraction. So if we open a front back, in here I already have the actual tacho data that was taken for this example. You normally wouldn't have this, but I wanted to show the actual RPM versus time trace versus the extracted one. And if we zoom in here, you can see that the tool did a pretty good job of estimating the RPM. Now let's take a closer look at some of the additional settings in RPM extraction. To change the processing settings of your color map, come under the Settings button, and you'll be able to alter the frame size, resolution, spectral lines, and increment of your color map. Now I want to point out the two other methods available to predict your order line. First, we have the 2 points method. Unlike the 1 point method where we drop just 1 point onto our order line, in this method we're going to accept 2 distinct points. Now when I click Predict Curve, you'll notice that the order is only predicted between the points that I've dropped. Alternately, we could use the multiple points method. In this method, you can drop as many points as you want as long as they're at least 1 increment apart. This method is great for order lines that are ratty or that the software has difficulty predicting with the 1 point method or 2 point method. Just like with the 2 point method, it's only going to predict the order between the point lowest in time and the point highest in time. It will not extrapolate out between the beginning of your time trace to the end of the time trace like the 1 point method does. Thank you for watching.